Hi everyone. What we're going to do today is just a review of what we did last class, which was on compound events. So if you want to write this in your notebook to follow along, I'm also going to post a blank copy of this sheet if that's easier for you to kind of follow along in your notes. And then I'm also going to be posting the key to this if that also helps you. So the first thing I want to do is just a review of our three main definitions. The first one is, what is a compound event? Well, a compound event is the probability of two or more simple events, and it's broken down into whether it's an independent event or a dependent event. An independent event is when the outcome of one event does not affect the outcome of the other event, where we take the probability of the first event, we multiply it by the probability of the second event. So think that we're rolling a die and flipping a coin, or we're picking a card from a standard deck and then we replace it back. Whereas with a dependent event, it's when the outcome of one event does affect the outcome of the other event. So we would take the probability of A, the first event, and then multiply it by our second probability after A has occurred. So think once again, we have that deck, but now we don't replace the card back. So the first thing we're going to look at is just practice. Is it an independent event or is it a dependent event? So scenario 1, Anne draws a colored toothpick from a jar. Without replacing it, she draws a second toothpick. This is an example of a dependent event because it's without replacing. Whereas in scenario 2, John rolls a 6 on a number cube and then flips a coin that comes up heads. This is an example of an independent event. So once again, we would take the probability of the first event and times it by the probability of the second event. So let's try some practice with some independent events. In these scenarios, if you draw a card from a deck numbered 1 through 10, and then we toss a die, we want to find the probability of each outcome. So problem number 1, we want to figure out the probability of picking the number 10 and then rolling the number 3. So once again, what's the probability of picking just the number 10 from our deck? Well, that's a 1 in 10 chance. What's the probability of rolling a 3? Well, that's a 1 out of 6 chance. When we multiply fractions, we multiply the numerators together and the denominators together. So we're looking at 1 over 60. We'll try to put everything in simplest form. In scenario 2, we have the possibility of drawing an even number from our deck of cards and then rolling an even number from our die. So our even numbers for the deck would be 2, 4, 6, 8, and 10. So that's giving me a 5 out of 10 chance. What's the probability of tossing an even number? Well, it's 2, 4, and 6. So that's 3 over 6. I can multiply the numerators together, giving me 15. Multiply the denominators together, that gets me 60. And that simplifies down to 1/4. The last scenario, what's the probability of picking a prime number from the deck and then rolling a prime number from the die? Our prime numbers is when it's multiplied by itself and 1. So here our prime numbers would be 2, 3, 5, and 7 for that deck. What's the probability of picking a prime number? Well, you have a 4 out of 10 chance. 1, 2, 3, 4. What's the probability of rolling a prime number? So that's only 2, 3, and 5 would be my options. So that would be 3 out of 6. Or when I simplify, 12 over 60 and 1/5. Let's look at some examples for dependent events. So our scenario says there are 4 red pencils, 6 green pencils, and 5 yellow pencils in a jar. Once a pencil is selected, it is not replaced. Find the probability of each outcome. So the first thing we should do is figure out how many pencils are in the jar. 4 plus 6 plus 5 is going to get me 15. Here, we're not replacing them. So what's the probability of picking a red pencil and then picking a yellow pencil? So the probability of choosing a red is going to get me 4 over 15. But now there's only 14 pencils in the jar. So the probability of choosing a yellow is going to be 5 over 14. When I multiply the numerators and denominators together, I get 20 over 210, which simplifies down to 2 over 21. In problem number 2, what's the probability of picking a green pencil and then another green pencil? So here what we're looking at is the probability of choosing a green pencil is going to be 6 over 15. But now I have 1 less green pencil. So now I'm going to have a total of 5 green pencils with 14 of them in the jar. When I multiply, I get 30 over 210, which is going to simplify down to 1 over 7. Our last scenario, we want to know the probability of picking a green pencil and then a yellow pencil. Well, the probability of choosing a green pencil, just like before, is 6 over 15. And now the probability of choosing a yellow pencil is now going to be 5 over 14. When I multiply, I get 30 over 210, or 1 over 7. So hopefully this refresher helped. We're going to do new material starting next time.